On the second video for this section, what is it, 8.3, I'm going to do an example of a function. We're just going to graph an exponential function, not the basic one, but a more general exponential function. So you'll notice I have this function f of x equals -2 times 3 to the x plus 1 minus 4. Okay, so I've taken the basic function, which would be 3 to the x. I've multiplied it by -2, so -2 is the coefficient. It's the coefficient of the exponential function. And then I've taken the x and I've added 1 to it. That's going to be a left-right shift. And then I've subtracted 4 from the whole thing, which is going to be a up-down shift, right? It's negative, so it'll be down. And so I'll show you how to graph this. The two really important things are, well, three things. Know what the basic shape is, right? That's the first thing. The second thing is find the asymptote. And the third thing is graph 2 or 3 points and then sketch in the curve. And so in your homework and exams, it'll probably say give 3 points that are on the graph. And you just have to plug in a number for x, evaluate it, plug in another number for x, evaluate it. And usually people pick easy ones that give you easy numbers or that make it easy to graph. So I'll show you how to do that. So g of x would be 3 to the x. That's the basic function that this f is built out of. It's been shifted left by 1. How do I know it's left by 1? You take the inside of g of x, which is x plus 1. You set that equal to 0, just like you do for vertices. Set it equal to 0 and solve. You get x equals -1. It tells you it's shifted left by 1. Then if you plug in 1, or -1, you get 2 minus 4, and that's going to tell you, well, it tells you where a particular point went to. It doesn't quite work like the vertex of a parabola, but it tells you where some point on the graph is. But you don't have to worry about that. At this point, you just want to know, set that inside of the exponential function. Inside of the exponential function is the exponent. Okay, so that's the inside of the function. We call that the argument. The argument of a function is the stuff inside the function. Okay, so anyway, so you set the argument equal to 0 and solve for x, and you get x is -1, means that you had to shift the whole thing to the left by 1. That doesn't help all that much, really, because it has a horizontal asymptote. So the horizontal asymptote is shifting along itself. What you really want to know is what's the up-down shift. And the up-down shift, fortunately, is easy. It's the number it's the constant number that's added or subtracted on the right. It says -4 or -4. That means it's been shifted down 4. So that means instead of your asymptote being on the x-axis, it's going to be at -4. Okay, that's the main thing. And then the rest is just a matter of plugging in points. So you don't have to worry. It's easier than parabolas. You don't have to worry about a bunch of stuff like finding a vertex, completing the square, none of that stuff. So I started graphing this. I put my asymptote first. Always do that first. With any function, you kind of want to draw your asymptotes in first if possible, because it gives you guidelines for where the graph is. So y is my -4 is the asymptote. And I just need some points, so I'll just plug in some numbers, make them easy ones. So like maybe I'll use x is -1, because I can see that if I put in x is -1, I get 3 to the 0, which is 1. So I get -2, -4, -6. See, it's really easy. If I put x is 0, it starts getting pretty small. X is 0, I'll get 3 to the 1. So that's 3 times -2 is -6 minus 4 is -10. And I probably did that. That's why it goes down here to -10. And then, well, if I put in 1, then it's going to be way down here. So I didn't. I went back the other direction. So let's see, I had -1 and 0, and maybe I'll go, I'm sorry, I had 0 and 1. Maybe I'll do -1. Wait, I had -1. I had -1 and 0. Maybe I'll use -2. It'll give me a fraction, but at least it'll be graphable. It'll be on this, in this scale somewhere. So, maybe you'll do one where there's a fraction, like you end up getting 3 to the -1. Usually that's what I would do. I would want my exponent here to be -1, 0, and 1. That usually gives a good graph. And then you just, draw a curve between them. And that's probably what I did. So I just wrote out what the equation was right there so I didn't have to keep looking at the top of the page, and because that makes me prone to make mistakes. Just double check it when you write it down. So choose 3 inputs that look easy to evaluate and give numbers, outputs that are not too big. Right, because then I'd have to draw a bigger graph. And I don't want to. So I did x is -1, and you can see why when you plug it in, right? You put it in, and I'm just going to calculate what it is, f of -1. Notice how I use f of -1. That way I don't have to write x equals -1, colon, underline, like I often do. I can just write f of -1 equals. That's a good habit if you plan to go on to more math classes, okay? So I just put -1 in for x right there, and you get 3 to the 0, like I said before. I actually kind of did these orally already. 3 to the 0 is 1, so you get -2 minus 4, which is -6. Right? So that's good. I can graph that. So I graphed that, -1, -6. And then, let's see, maybe I want, I probably use 0 next. Yeah, 0. 0 is usually nice. So 3 to the 1 is 3. So that's -6 minus 4. And so then I graph that point, 0 minus 10. It's always kind of nice to get where x is 0 because that's the y-intercept, right? And you can see which direction it's kind of going. The tail will be on the left. But it's still a little confusing, so I want one more point. And I'll probably choose like x is -2. I mean, you can look at the graph and see where do you want to get a point. I want to point to the left of the 2 that I have now. So I'll try -2. Right? That gives me 3 to the -1, which is 1 over 3. So it's -2/3 minus 4. So it's -4 2/3. If you want to think of it that way. I wrote it that way, but it's actually easier to graph as, right, -4 2/3. So -2 for the x-coordinate, -4 2/3. It's getting pretty close to the asymptote -4, right? It's 2/3 away. And that's kind of, so that's 3 points, and that's actually a pretty good drawing. Surprised myself. So that's what the graph looks like. You don't really want to guess from, it's a negative coefficient, it shifted to the left by 1. I mentioned that as an aside, just so you know. Actually, what happened was this point here used to be the y-intercept, right? But it's kind of confusing because this looks like, it's going down. But the base is greater than 1. So why isn't it exponential growth? It is exponential growth. It's just that the whole graph has been flipped upside down by the -2, right? If you flip it back up, you'll see it's going whoop. Negative decay, or exponential decay, the tail goes this way. The tail is on the right. Exponential growth, even if it's not growing, the tail's on the left. Right? It would be growing, but we flipped it upside down with the -2. Okay, enough of that. Now let's do some applications.